hour live. Okay. All right, so I've got the document open.
All right. Oh. Okay, my husband's calling me. 1 second.
Okay, no worries.
Hey. Okay. Oh, yeah. Okay, I will be right back. My husband needs me to open the garage door really quick.
Okay, no worries.
Bye.
You sound in chaos. I just caught that and it sounded in chaos. Are you okay? Oh, I didn't know that. You already know what I called that. Total of $284. Yeah.
He is officially handed off.
Okay.
Good. Okay.
Awesome.
So the part 2 of the preparation.
Other stuff I have to do. So it's kind of like,
So I don't know about you, but for this one
no.
seemed a lot easier for me than last week's.
Yeah, I don't know, but I'm hoping it's because, I hope it's because I understand it better and not just because I'm doing it.
Yeah.
That commonly happens to me with math. I'll be like, oh yeah, I get it.
And then not really. That happens to me all the time too.
And I'm like, we learned this?
Yeah, I totally understand.
I love you too.
All right, so
Okay, so we're doing number 5, right?
yes, number 5.
Okay, so a 4-sided die has 4 possible outcomes for each roll. 1, 2, 3, or 4. Calculate the mean of this discrete random variable.
All right, so I'm pretty sure for this one, this is the one where we take each of the outcomes and do it in fraction form, and then add up the mean in that slightly kind of complicated way. So it says, in finding the mean of a discrete random variable, it's important to be able to compute the population mean to introduce this idea. That's not what I'm looking for. Stop it. Go away. Go away. Go away. Okay, here it is. So I think this is the one where we take the proportion, the fractions with the probabilities, and add them together for the mean.
Okay, so we do
Does that sound right?
So we do the value, right? So there's 4 values, so it would be like 1/4 equals 0.25, right? Is that how it would be?
Maybe. I thought this was the fraction one, so I was thinking it would be like, so a 4-sided, oh yeah, 4-sided die. Yeah, you're right, okay. I was thinking it was a 6-sided die, because, yeah, no, you're right. Okay, so
because then we turn it into, so is it in 3 columns? Is this the one that's in 3 columns?
I think so, yeah. Because on here it shows, so they did the example of a man who rolls a die 6,000 times. And then how you find the sample mean. And so he did a column 1 through 6 and how many times you rolled it and what the sum was. And then he just took each of those fractions and times them by each other and then added them all together and divided it by 6,000.
Okay. So
I think that's kind of the same thing we're doing here.
problem. Yes. Yes. It's the only thing I'm trying to place correctly is okay, I get it. So we're just gonna do it 4 times then, right? Since it has 4 possible outcomes.
Yeah.
Okay.
So it'd be 1, 4, 2, 4, 3, 4, 4, 4, right?
Well, let me see.
Well, it didn't really tell us how many times it was rolled.
That's the thing. That's what I'm trying to figure out. Because are we just gonna? Does it just want us to say, okay, there's only 4 outcomes, so you only roll it 4 times?
That's what I would assume since it didn't give us an actual number for how many.
Like the 6,000 one. I'm trying to see if there's another example. Like it's better when I have a direct, like one that directly
Matches exactly.
Otherwise, I just am lost.
They get more complicated as you go down rather than easier.
Right. Dang. I wonder if there was anything in the video. I just didn't get to that. I was planning on doing it, and my older son was like, "Can you please play with me?" And I was like,
Hey, no worries, man. I don't have kids, but I would totally put them first if I had any. Why don't we try doing it the way that we think and then check it on the answer sheet and see if we did it right, and if not, then we'll go from there.
"Okay."
All right, so it'd be
You're saying we do 1 or we do like 1/4, and then 2/4, and then 3/4, and then 4/4, like that.
and then divided by, let's see, divided by,
Just by 4, since we're saying there's 4 outcomes.
yeah, divided by 4. So let's give that a shot. See if we end up with the same answer. So 1/4 and then 2, 4, 3, 4, 4, 4. Alright, I'm gonna get my calculator. Okay. All right, tell me when you're ready.
Okay. I got my answer, but it does not look right.
I have my answer and it doesn't seem right either. Did you get 0.625?
Yes.
Okay.
I'm like, that doesn't look right.
Yeah, how could that be well, maybe it could be the mean, because the mean is that, I don't know. All right, let's look at the answer sheet.
Okay.
That's nuts.
So basically, we were supposed to do 1/4 for each value, because that's how you could roll that one value.
Right.
So it's 0.25. So then you do 0.25 times 1, and then 0.25 times 2, 0.25 times 3, 0.25 times 4. I'm assuming you add those all together and then you divide by 4.
All right, so we had the right formula. We just forgot about the p
Right.
and x
So
value
that's the right
part.
idea, right? But it's
Right.
like we just didn't execute it correctly.
We just messed up on the technicals.
Yeah.
All right.
That's a life of math, I feel like.
Right. That's how I feel. All right. Let's try it one more time now that we know this, even though we know the answer, and see if we come up with that answer. See if we can figure it out the right way. I'd like to know how they put a chart in there. Okay.
Okay, so basically you just add them all together. You don't have to divide. That, at least that's what I got. Because the answer is 2.5, and I just
That's what you did, and that's what it came out to?
yeah, I just added like the 1 times 0.25 plus 2 times 0.25 plus 3 times 0.25 plus 4 times 0.25, and then it came with a sum of 2.5.
Awesome.
So I guess you don't have to divide since it's just averaging them all together. Just trying to make sense of it without like, why don't we have to divide it?
Maybe I did it wrong, but I didn't get the same thing. So I did. So 1, clear. Let me pull up the answer sheet again. Check my math here.
No, I just put in.
0.24. So 0.25
I'll
times
be higher.
0.25 times 3 times 0.25 times 4. Okay, you're right. Adding them together. That's what I got too.
You just added it all together and it worked.
Yeah, I did. That
I
doesn't seem right.
Why though? Because on the example, it was like it divided by 6. I mean, you know, the 6,000 when they divided by 6,000 because that's how many times they did it. So that makes sense.
Oh, that's true because we didn't have a number that they rolled.
Right.
Oh, okay. So we don't need to divide then.
That's what I'm guessing.
All right. That makes a lot more sense.
We'll justify it that way, right?
I was like, why? Why doesn't this make sense?
Yeah.
Okay, that does make a lot more sense.
Okay. So then the next one. Okay, the next one is standard deviation with the same thing that we have. So we have the sum. So what do you do after you have the sum to get the standard deviation?
You got to do another complicated table. That's what I remember. So this is the standard deviation. So because we have the sample mean, we can fill in part of the proportion, not the
Okay.
proportion, the want, you know what I mean? So for column 1, it's the value, so the x. Column 2 is the px, like we just did. Column 3 is the value times the proportion, so it's x times px. And then column 4, to find the standard deviation, you have to do x minus the sample mean squared times px.
Okay, and you have to do that for every single one. And then after you get all of those, you add them together, and then that's the sum variance, or what? Because on the table on column 4, it has each one like for the first value. It does that whole.
Yeah. So at the very bottom, it says the standard deviation is the variance.
Oh, okay. So you get the sum variance, and then you take the square root of it, right?
Yeah.
I see. Okay.
And the sum variance is just all of that added up.
Okay. Try it, right?
All right. So let's do this. Yeah. Oh my
1
gosh. Okay.
minus. Okay. Try.
I feel like I need. Hang on. I feel like I need to go get a notebook because this is taking some writing. This. I'll be right back. Again.
Okay.
I'll be right back.
1 minus 1.5 squared times 0. Oh, no. Times. Oh man, what should I do? What? Yeah. Okay.
All right. I'm back. I had to get some paper because this is more complicated than I thought it was
Some
going
kind
to
of
be.
defense, right?
A little bit, you know. Okay. I talk to myself. I hope you don't.
I keep doing the same thing. That's the only way I can get through math.
It helps me think. I'm like, what am I doing with my life?
Wait until you have children.
Just always talk to yourself.
Yeah, it's like that's the only thing you do. Like that's the only way you can think because there's so much stuff going on.
Probability. So we just found. No, we just found. Okay, so and then x is the fraction, just 5. Just the same for all of them. Just nice. I just wonder if anyone else in our class watches these videos and watch
like,
me.
huh,
That's interesting.
doing that right. Very interesting.
Fascinating. Yeah, you know.
You know what I find out though? We need to go on there on the thing and sign up for a time limit student.
Oh, I saw that. I was gonna ask you about that. Wait, so this, yeah, the teacher aid.
I figured we could just sign up for a Tuesday night to keep on just, you know, only counting on Tuesdays.
Yeah, I think that's a good idea. Did we decide that we wanted to meet Thursdays too to do the other one?
Yeah, I think that's best because then it's not like it's like if we're trying to cram too much in if we try to do it all in one night.
Yeah, I think that's best. Okay, so 1 minus the sum, which was 5 squared times.
Have you done 3 minus 2.5 squared times 2.25 yet?
No, I am on the last column, but I'm only on number 2.
Okay. I'm just wondering because I just did it and it came with like I must have done something wrong.
Right after I finish this one, I will go and check it. I'm just about done here. Find all the answers.
Maybe I did do it right. Okay, we'll see. Okay. Add them all together then.
Calculator. Need a better calculator, one that can square things.
Okay.
That's interesting.
Where's I can't find my square root button.
That's what I was struggling with myself.
Here's my square root button. I know it's on.
Okay, 1 minus 2 times. You stop. 1 minus. When you're doing the square root, you can't use a negative, right? So you would just have to do the positive.
Right, no negative. Well,
Even though it has a
even
negative.
if it's a negative, it would come out a positive number.
That's a good point.
Right? No, that's if it's being squared. The square root, I don't know.
Oh, because we're squaring it, not square rooting it.
Right.
Ah,
So
that
you
could be
square
why
it,
it doesn't make
and
sense.
then you would, to get the standard deviation, square root it.
That's right. That's where I lost it. All right. Once again, I see why we do this in groups.
Yes. Keeps everyone on track, right?
I feel like it does. Might just be me.
No, I would totally fail if we didn't do this in group. It's easier to have someone to talk it out with. Make sure you're making sense.
All right, I still got a negative number.
Really?
Yeah.
Okay. So we did all the mumbo jumbo for the number 5, and then you did the 1 minus 2.5 squared times the 0.25, and then
Yeah. Yeah, I got negative 13.125, so I must have done something really wrong.
Really?
Yeah, let me try this again. Okay, 1
118.
minus 2.5 equals, and you square that, equals that, and times that, 5.2. Okay, I got negative 0.5625.
So it must be your calculator, because if you do that, if you do the 1 minus 2.5 squared times 0.25, it's
Uh-huh.
equal 0.5625.
It what?
It's supposed to equal 0.5 or 0.5625. That's what it's supposed to equal.
So that is what I got, except I got a negative. Why does it still have a negative?
Okay, it must be because instead of when you did the 1 minus 2.5,
Mm-hmm.
that would give you a negative number.
Yes.
And even though you squared it, even though you squared it, it didn't do the negative times the negative equaling a positive.
Oh, that's true. So the calculator just didn't pick up on that.
Right.
So I just have to use my brain power, which
Positive.
I'm very good at.
Well, who wants to do that?
Right? That's just boring. Okay, this should go easier now that
Right?
you figured that out. Thank you. I just expect the calculator to do everything.
Well, it should do it. That's why you expect it to do it.
Okay. There we go.
What confused me, so like when you get like the numbers from that equation, there's
Uh-huh.
like, so the first one and the fourth one are the same numbers, and then the two middle ones are the same number as well.
Yeah, I'm finding that out.
I was like, that can't be right, but it is right, because then when you add it all together, you get
The answer that's on there.
and then
I haven't quite got that far because I have some struggles. But
well, it's good to struggle through it now instead of like the quiz, right?
right? That's what I feel like.
So much better to do it now.
That's fine. Alright, so the last one. Yeah, the last one. Same as the first one. Very straight. And then you add all that together. Going down. Hey, focus. Going down. So you add all that together and you square it.
You square root it. You take the square root of it.
Square root of it, right.
Yeah.
All right, and then if that answer matches here.
Did you get it?
I did. Yep.
Awesome. Cool.
Is that all we have? That's it.
Yeah, for this one, there's only 2 problems. So,
Probably because they take you a million years.
yeah, they're like so time consuming, right?
Seriously. All right, should we go take the quiz?
I say we do it.
All right, let's do it.
We're on lesson 4, right?
Yes, lesson 4, and then Thursday will be lesson 5.
Cool. All right. Okay.
The quiz has like, what, 13 questions?
It does?
Yeah.
Okay. All right. So give all your probability answers as decimals. Do not give them as percent. Okay. Human blood can be classified into one of 4 basic types, O, A, B, and AB. The proportion of people in the population of the U.S. with each of these blood types is summarized in the following table. Use this data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution. Well, I don't know.
Okay, so it talked about this in the book. So this was crazy. The book was talking about things that are random or not actually random because they follow these certain patterns of our subconscious, which I found
I read that, yeah.
found that was kind of creepy personally.
I was like, what?
Yeah. So when it's talking about probability distribution, we're allowed to use the book, right? Or are we not allowed to use the book?
I think we are.
Okay. If we're not, you know, it's recorded that we're using the book, so then we'll know.
We're allowed to.
So when it was talking about the probability distribution, let's see, where do I want to go here?
Oh, this is the rules part, right?
What's that?
It's the part where it like tells you the rules.
Yeah, the 3 rules of probability, and then underneath that it talks about randomness. So it's like, what does it mean to be random? When something is random, it's not just haphazard. This is a very clear pattern, blah, 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 blah. The entire pattern or the entire distribution is that each of the numbers is follows a pattern of some kind.
Okay.
So I feel like the answer to that question would be yes, because they probably follow some pattern, even though we don't know what the pattern is. I think that's what the point was, that things that are random always follow some kind of pattern. So it is a probability distribution.
Okay. That sounds right to me.
Okay.
That only makes sense. Because pretty much nothing's random. There's an underlying something, rhyme or reason, right?
Right. That's what I think, yeah.
Okay. So then we do number 4 then.
So it would be true. If we get it wrong, we can blame me. All right. What is the probability that a randomly selected person in the U.S. has type O blood round to 2 decimal places? Sure, let's just make life complicated. I'm just sick of plating. Okay.
I hate rounding. I always feel like that's where I get a lot of my problems wrong. I'll get all the math right sometimes, and then I'll round it wrong.
Right. All right. So the blood type O. So I think first we would have to add up all of the things to find out what it is.
So the blood type is like our value, right?
Yeah. The blood type is the value. The proportion is the. We have to use that to find out the probability. So I think we add up all the proportions. It's weird that they didn't give us to us in fractions. Okay. 0.4.
Oh, okay. Yeah. So we just don't have to do the fraction part. It's already there for us. Thank you.
Yeah.
See, I need you to make sense for me because I'd be like, wait, I don't know what I'm doing now.
Yeah, I think we help each other because I was lost on that other one.
Okay. So that's our second row, right? So then we have to do that crazy Okay, then we have to add all those together, right?
Yeah.
Is that what we did? Okay. Got it.
You're such a fast adder. I keep making mistakes, so I have to start over. Need a calculator. Alright, so did you get that they all added up to 1?
1 second. My calculator just decided to say I don't even know what it's doing right now. I'm
That's really fun.
let me see if it'll work this time. I put all the stuff in and it's like, then ask me a question. I'm like, no.
I think we're gonna have
I didn't answer my question.
to.
I got one.
Okay, I did too. That doesn't really make sense.
Okay, so then, okay, so now, okay,
So you have to take 0.45 out of 1 to find out what the probability would be, don't you?
okay, when we did the other, where did the 0.25 come from? Remind me.
Or I said 0.45. I meant to say that if I said
Well,
2.5.
for the practice problem that we did
Uh-huh.
in the preparation.
Yeah. The 0.25 came from, so we,
Oh, okay. It came, so what you're saying is we multiply by that 0.45, right?
say that one more time.
So we would do what we would do for the next column, because we're trying to find, well, the probability, is the probability just us saying 0.45 times 1?
I don't know if it would be times 1 or taken out of 1, because the probability would be like, okay, so this is what O is over everything else. If that makes sense. So everything added up all together would be 1.
Right.
So it'd be 0.45 out of 1, which I added up to be 0.55. And I just don't know if that's right.
Oh, like you put it like a fraction, like 0.45 divided by 1? No?
No, like I subtracted it, like, so.
Oh, I see. You did 0.45 minus
1 minus 0.45.
1. 1 minus 0.45?
Yeah.
Okay,
Because my thinking, no idea if this is right, my thinking is if all of it adds up to 1, and we just want to know what O negative is out of that 1, then everything left over.
okay.
So wouldn't, what the heck? So, this is interesting.
This is supposed to be easy.
Right?
Okay.
The way that you do proportions, or the way that you do probability, is you take the amount of something that you're looking for, like red balls, out of all the rest of the balls. So if there's 2 blue balls and 4 red balls and 6, green balls, you add up all the colors of the balls, and then you take the color of the blue ball. So if there's 2 blue balls and 68 other balls, then the fraction is 2 over 68, which can be reduced to something. I don't know what it is, and then to get the decimal, you divide that fraction. So maybe we have to turn these into fractions. All of them. That just really sucks. So it'd be 45 over 100, 40 over 100.
Okay, I'm gonna apologize right now. There's someone like picking up our piano, and you're gonna hear a lot of banging.
Okay.
They're like, I know they're gonna hit the wall 80 times before getting it out the door. Just so you know, there's nothing too crazy going on here. It's just,
I'm totally not worried. Don't even worry about it. Okay, so let's see. So add all these up.
Reading the book because I really thought this would be a lot easier.
There wasn't anything like this in the book. Do you want to skip this one and come back to it?
Yeah, let's try.
See if the other ones are not as hard.
Yeah, we can only help, right?
I think so, maybe. What is the probability that randomly selected? Okay, let's skip that one too, because it's related to the same one.
Watch,
Okay.
they're all like, and pick what you got from number 4. And
Use it on every single rest of the problems. Great! Okay. All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. Cute. The dogs were trained to lie down next to a specimen derived from the bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of specimen. 7 bowels containing urine were lined up in a random order. 6 of the samples were from the patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. So this seems easier. So this one is a fraction one. I can do fractions. I don't know what the crap they're talking about with decimals. Okay.
You got me on both of them. It's math in general for me. So
Yeah, right. Okay, so if the dog guesses at random, what is the probability they will correctly identify the dish containing the specimen from the bladder cancer patient? So you have to add up the ones who are bladder cancer patients and the ones who are not. So there were 6 that were not and 1 that was. So it would be 1 out of 7, right?
yeah.
And so then you would have to divide that. Oh, hey, if you flip it there, Sherry, I just learned that if you flip my phone sideways, it becomes a real calculator instead of the stupid one.
On your smartphone?
I do have a smartphone, but I'm not a smart person, apparently. Okay, 1 divided by 7 equals that. Round to 3 decimal places. So
Oh, cool. Mine does that too.
0.143 is what I got.
It's like magic. Okay. Did you just do 1 divided by 7 then? Or what
Yeah.
did you?
Yeah, I did, and then round it up to the 3rd decimal point.
Which would be 0.143, right?
That's what I got.
Okay.
All right, that one made sense.
Kind of.
I could handle that.
Until we submit it and it's like,
Yeah, right? If it's wrong, I'm going to be like, okay, I quit this
I'm
class.
just going to start crying.
I'm sorry, I'm just going to quit school and be a mime for the rest of my life. Just can't handle this. All right. Do you want to read number 7?
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times.
Not
It is
bad.
very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder.
I just kind of feel like that's a given. 22 out of 54 times, and it's really unlikely. That probably provides strong evidence dogs can detect bladder cancer. It's not random.
That this dog would do this well by random chance.
Do you agree?
Is there like anything in the book about this, or are we totally blind?
Yeah, so the book, when it's talking about things that are random, it's like you should understand that things that appear random are not always random. So if something happens by chance and it's not likely that it would happen, there's usually another reason.
So you're
So
saying that this does provide strong evidence.
yeah, I'm saying it does. So if it says it is very unlikely the dog would do this by chance, then the other answer would be, well, then it must be that dogs really can detect bladder cancer. It's not random.
I think you're right.
Sweet.
Okay.
Hey, look, a question about M&Ms. You can't go wrong with M&Ms.
You're right. Yeah, I wish I had M&M.
Yeah. All right, M&Ms are small chocolate candies. Oh,
I did not know that.
Copernicus over here. The M&M website previously indicated that in the U.S., the distribution of the colors in a bag of plain M&Ms is given in the following table. Oh no, more decimals. It's not good. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Okay.
Hold on. Okay, my husband can't figure out how to remove the legs from the piano. And the guy from Craigslist is here right now. So I'm gonna go help him really quick.
I will keep working on this. You go, girl. Be superwoman. Get those piano legs off of there. All right, let's see. Hey, Mercedes, how was your date? Sweet. Right. This doesn't really make sense. .84. Reaching the nice probability of drawing a red. 0.84. Hey Mercedes, remember the number 0.84. Yeah, remember that for a minute. Was it 0.84? All right, and the fraction would be nearest two decimals, 0.15. Just doesn't really seem likely. We're not gonna do well on this quiz. We're just not. Wonder if you can retake it if you really suck. Why is there a question about the green one? The green one is scratched out. What a horrific question. Are you kidding? There's 2 questions about the green one?
Okay. All right. Sorry.
Shuri, you gotta see this.
Oh my gosh. Okay. If you reach into a bag of M&Ms. Okay.
That one's not too bad. That one makes sense to me. Look at 9 and 10.
9 and 10. What is the probability that a randomly selected candy is green?
Is it just me, or is your green scratched out?
There's no green.
There is no green.
There's not a green.
So how the crap are we supposed to find the probability?
Okay, do we assume that there's no green one?
I guess, but so is it 0?
What is the probability? Well,
This is
there's
like
no
a trick question.
I'm just gonna put 0 there because seriously, it's like someone colored it with blue. Okay.
Yeah, someone colored it with blue.
Yeah. Hope
Maybe
we get that
we'll-
one right.
Right? If we don't, I don't freaking know what the crap it's supposed to be.
Okay.
All right, for number 8, what I did was I added all of them up, and then I took the red divided by the total.
Okay, you added up all the decimals, and then you just
Took the red divided by the total.
let me just. Oh, it's so dark in here. They're trying to move the piano out right now. So I thought there were just these screws that held the legs onto our piano, but apparently that's not what it was.
Oh no.
They were like screwed on, and I was like trying to screw it off, and they're like, no, I think they're glued, and I'm like, I don't think so. I don't even know my own piano. Sorry, guys. Okay, my calculator keeps doing this weird thing. Okay, I gotta reset it. Okay. One more time. For the red, you added them all together.
Yeah, I added them all together, and then I took red divided by the total.
Okay, you took the 0.13 divided by what you got, right?
Yes. I think. Yeah. Yeah. Maybe. Yes.
Let me just. Okay, so you got 0.84, right?
Yes, for the total?
Yes.
Yeah, I did.
So then it was 0.15. Oh, we rounded to 3 decimal places, is that what you said?
This one says round to 2 decimal places.
Oh, it is? Okay, so 0.15 then, right?
That's what I got. And then for number 10, I added all of them up except the red one. And then I divided that by the total.
What is the probability that a randomly selected candy is not green? Well, all of them are not green. All of them are. So what did you do to do that one?
So I added all of them up.
Okay,
Oh
so
wait, I thought it said red.
0.84. See, with the green.
So wouldn't the that a candy is not green going to be 100%?
That's what I said.
So it would just be 1. How would you round that to 2 decimal places?
So
Why is this so hard?
yeah, I say we put 1. That's the only thing that is possible for that question, right?
That's what I think, because if they crossed out the green,
There is no green. You can't do anything with green. All of them are not green.
yeah, I'm going to leave it as 1. It fits with the rules. So maybe it's not a trick question. Maybe they're just testing their knowledge.
You're right.
All right. The ACT scores of students admitted to a medium-sized public university in the western U.S. were taken from capex.com. The following summary statistics were calculated.
Okay.
Use the information to answer the following questions. Half of the observations are less than or equal to what number? What?
Did we learn about this?
I don't remember learning about this. I read the whole thing. There was nothing about less than or equal.
The only part I remember is about being less than or equal to is like in the rules for the numbers from probability. You know what
Yeah, I remember that. Yeah.
That's
Like-
the only thing I remember.
Like number 13. Let's skip to number 13. That one looks a lot easier.
Okay, you're right. It does. Okay.
Oh, okay. I already think I know which one it is.
If the probability is high. Is it the third one?
That's what I said. I think it's the third one.
If the probability is high, then the probability is positive. If the probability
Yeah,
the probability is negative.
that's definitely not one of the rules.
I did not read anything about
Yeah, that's definitely not one of the rules.
that. Oh man.
Based on the information on the table above, the top 25% of the students scored above what number? I'm telling you, these were not things that we learned.
I'm beginning to wish that I watched that whole video. I wonder if it was on there.
Beginning to wish this
You know what
class
we can
was
do,
not
though?
so hard. What?
It says we can save this for later.
That's true. Do you want to save it and go watch those videos?
Like maybe we should save it, watch the videos, and then come back to it. Cause did you watch the videos last week? Did you get a chance to do it all?
I did. I didn't find them helpful personally, but
Really? Because I watched them before yeah, you better give that to me because you'll spend that. Like I watched them before I did the reading, and for some reason everything totally clicked for me watching that
really.
rather than reading.
Huh.
But I say we save it and then we watch the videos and then come back to it.
All right, let's do that. Do you want to stay on or do you want to hop off? Well, then I have to stop the broadcast.
Well, I mean, he said he's not grading the broadcast until week 3.
That's a good point.
And ours is almost an hour long anyway.
That's true. All right.
So I say it's okay if you stop it and then we'll save it and then watch the videos and then we can come back on and do it back together again.
All right, that sounds good. Do you want to just email me when you're done and I'll email you when I'm done?
Sounds good.
All right, see you soon.
All right. Bye.
Bye.